let's continue with how to check differentiability of piecewise functions. So when we have piecewise function, we should check continuity first. You know how to check continuity. Check whether the function is defined. We have three conditions if you remember. Check whether the function is defined, limit exists, and the value of the function to be equal to value of the limit. You check these conditions. If function is not continuous, we directly say not differentiable. But if it is continuous, we should take derivative of each condition and check limit for each condition. If limit exists at that point, then we will say it's differentiable at this point. If not, it's not differentiable. Okay. First we check continuity as we did in chapter 2. If it is not continuous, not differentiable. But if continuous, we can take the derivative. Take derivative of each condition, then check the limit, right and left side limit. If they are same, if we have a limit, then we will say it's differentiable. So let's take a look at the first example. Study guide question. Is this function differentiable at x equals -2? First condition, we check continuity first. This is our first step, check continuity. What is the first condition for continuity? Having a defined function at the given point. F of -2, 1 minus 4 times -2 minus -2 squared. This is 8 plus 1, 9, minus 4, 5. So it is defined. First condition is satisfied. Second condition, check the limit. Limit as x approaches to -2 from the left. So less than condition will give me left-sided limit whose function is x squared plus 4x plus 2. When you substitute -2 for x, -2 squared 4, 4 minus 8, -4 plus 2, -2. What about right-sided limit? So remember, for right-sided limit, we check more than condition, whose function is 1 minus 4x minus x squared. So -2 for x, it's 9, minus -2 squared, 4, 9 minus 4, 5. So limit exists. No, it doesn't. Here I have 5, here I have 2. So right-sided limit is not equal to the left-sided limit, then limit does not exist. So the second condition is not satisfied, then we say f of x is not continuous. If the limit, if function is not continuous, then we can directly say it's not differentiable. So don't bother taking the derivative of each condition and stop. You can stop immediately when you figure out it's not continuous. So there is a jump apparently at -2. If there is a jump, it's not continuous, so no need to continue. Okay, let's take a look at another question which is differentiable. This one, checking continuity. First case, a function case. The value of the function at 1, is this defined? 1 squared plus 1. Yes, it is defined. The first condition is satisfied. Second condition, check the limit. In order to check limit for piecewise functions for less than or more than, we check right and left side conditions. For left side, 3x minus 1, which is 3 minus 1, 2. For right side, we use more than condition, x squared plus 1, which is 1 plus 1, 2. So right-sided limit is same as left-sided limit. So limit at as x approaches to 2 of f of x is 2. So I got the second condition 2. Third condition, is the value of the function same as the value of the limit? Yes, f of 1 is equal to limit as x approaches to 2 of f of x, which is to their all 2. So I got the third condition too. So we can say function is continuous at x equals 1. Okay, now next step. I am not done. I am done with the first step, checking continuity. Now check differentiability. So you should take the derivative of each condition now. F of x equals derivative of x squared plus 1, 2x, x is more than 1, 3, x is less than 1. Okay, now we check the limit again, left and right sided limit. Limit as x approaches to 1 from left, which is 2, and limit as x approaches to 1 from right, which is 3. So right-sided limit is not equal to left-sided limit. Limit as x approaches to 1 of f prime, sorry, here, f prime of x does not exist. So since limit does not exist, there is no derivative, we can say, at 1. So it's not, f of x is not differentiable at x equals 1. It means f prime of x does not exist. F prime of 1 is undefined. Okay. Here we are looking for derivative of the function at 1. So since we didn't get anything, since limit does not exist, f prime of 1 is undefined. F of x is not differentiable means f prime of 1 is undefined. Alright, so these are the two types of questions that you may face: whether the function is not continuous, so it's not differentiable, or function is continuous, so we check differentiability, we check the derivative of each condition, it's not differentiable, or it might be differentiable too if the limit were like this. Let's take a look at this ministry question. 2023 first attempt. Which one is differentiable at x equals minus 2? So we check a continuity of each one by one. It will take time. Take the function is defined. Function a is defined. There is equal to condition. B is defined. C is not defined, so we can directly eliminate C. D is defined. So the first condition checks for A, B, D. Second condition, check limit. What is limit? From the left, this is the function. Negative 2 squared, 4 minus 4 times 2, 4 minus 8 minus 4 plus minus 2. What about right-sided limit? For right-sided limit, we use this function. Substitute negative 2 for x. So 8 plus 1, 9. Minus 4, 5. So right-sided limit is not equal to left-sided limit, so it's not continuous. So no need to take derivative. Do the same for the second one. Left-sided limit, use this function, negative 2 for x. Negative 2 minus minus 2. So negative 2 plus 2, which is 0. Right-sided limit, negative 2 plus 2, 0. So right-sided limit is equal to left-sided limit. So limit exists and the value of the function is also 0. So the second and third condition are met. Now, so I can continue with the derivative for option B. So what is f prime? It is negative 1 for the first condition, 1 for the second condition. So does the limit exist from left and from right? From left, negative 1. From right, 1. So negative 1 is not equal to 1. So limit does not exist. Then we say f of x is not differentiable. So option B is also false. Last option, apparently, this is our answer. So option D. Let's check a limit first to check continuity. Limit as x approaches to negative 2 from the left of 3 minus x squared, which is 3 minus 2 squared, 4, 3 minus 4 minus 1. Check right-sided limit. use this function for x plus 7. So 4 times negative 2, negative 8 plus 7 minus 1. So right-sided limit is equal to left-sided limit, which is also same as the value of the function. So all three conditions are met. So this function is continuous. If continuous, we can check differentiability. We check the derivative. What is f prime of x? Negative 2x for the first condition, 4 for the second condition. Now we check limits. If limit exists, it's differentiable. Limit as x approaches the minus 2 from the left of negative 2x, which is 4. Limit as x approaches negative 2 from the right, whose function is 4, which is also 4. So right-sided limit is equal to left-sided limit. Limit exists, then function is differentiable at x equals negative 2. In other words, f prime of negative 2 is defined whose value is 4. Okay, this is how we solve these kind of questions. We check continuity first. If it is continuous, take the derivative and check the limit. If limit exists, it is differentiable. If not, it's not. So answer is D. All right. Next question. Is absolute value x differentiable at 0? So absolutely no, because there is a corner. No need to solve. We have methods of solving. We can write this as piecewise and solve, or use the first technique that we solved in the beginning of the lesson. But it's not necessary since there is corner. What makes absolute value 0 is 0, then it's not differentiable. Similarly, the study guide question, there is a corner at what makes absolute value 0? X minus 2, 0, x is equal to has corner. At that point, the function has corner, so it's not differentiable. But is it continuous? Yes, you know the graph of piece absolute value functions. This one is something like that. It's V-shape or upside down V-shape. So there is no interruption, no hole, no jump, no break. So it is continuous, but not differentiable. So no need to solve these kind of questions. The answer is obvious. Okay, the next one. Here, this involves differentiability and the definition of derivative, the limit form that we studied in the previous lesson. So what does that limit form mean? That limit form indicates the derivative of function at what? At c, which is 1, right? So this is about f prime of 1. So it's asking about that limit. It's actually asking about derivative of the function at 1. So what's derivative of this absolute value function? It's absolute value function. What makes absolute value 0 is 1. So there is a corner. So f of x is not differentiable at the corner point. So not differentiable means f prime at that point is undefined. It's a very smart question. All right. So final question about these kind of functions. In the book, find the first derivative of this function, absolute value function. In order to take the derivative, we should write the function as piecewise first. Let's write this as piecewise. Or we can just use the first technique that we studied. Okay, option A. On the first part, x times absolute value x. You know that the absolute value x can be written as piecewise as x when x is positive, negative x when x is negative. If this function is multiplied by x, you multiply everything by x, right? So it will be x squared and minus x squared. So this is the derivative. On part 2, the second part B, is asking whether f double prime 0 defined. So what does that mean actually? It means f double prime of 0 defined means f prime of x is differentiable at x equals 0. So if f double prime of 0 is defined, then it means f prime of x is differentiable at x equals 0. So we're going to check differentiability of this piecewise function. So let's remember what to check when we check differentiability. We check continuity first. If continuous, we check the derivative, limit of derivative. So first check continuity. First condition, function is defined. Yes. Second condition, limit exists. Let's see. Limit as x approaches to 0 from the left, whose function is minus x squared, which is 0. And limit as x approaches to 0 from right, whose function is x squared. Substituting 0 gives you 0. So right-sided limit equals left-sided limit. So it also checks. Last condition, the value of the limit is 0. The value of the function is also 0. So third condition also checks. Then the function is continuous. What function? F prime of x is continuous at x equals 0. So what's our next step? Our next step is taking derivative of that piecewise function. So we already took derivative once, so this is second derivative, f double prime of x, which is equal to, take derivative of each condition, derivative of x squared to x, when x is more than 0, derivative of negative x squared is negative 2x when x is less than 0. Now, check the limit. If limit exists, it's differentiable. If not, it's not differentiable. So limit as x approaches to 0 from left-sided function is negative 2x. When you evaluate the limit, it's negative 2. Right-sided limit, the function from right is 2x. Evaluate the limit, it's 2. So right-sided limit is not equal to the left-sided limit, then limit does not exist at 0. So if limit does not exist, f prime of x is not differentiable at x equals 0. In other words, we say f double prime of 0 is undefined. Okay, this is also a ministry question that came once in Mazari. This part only, whether f double prime being defined or not. So these are the steps. We do the same, nothing changed. Okay, we studied how to check differentiability of piecewise functions, absolute value functions, and the first type, the first time we studied in the first video. So in this video we studied the differentiability of piecewise functions and absolute value functions, since we can write as piecewise. So the second part of this video is differentiability of other functions. So if we can, as I mentioned in the beginning of the first video about this topic, if we can take the derivative of the function, so don't bother using the other techniques. So just take derivative and see if it is defined at that point. If not, it's not differentiable. If it is, it's differentiable. It's pretty simple. We don't need any other way. We just take derivative. This question, for example, take its derivative immediately and see if it is defined. F prime of x, derivative of the square root function is derivative of inside divided by 2 square root of the same. So now, is this function defined at 1? It's a rational expression now. Look at the denominator. What makes denominator 0? When x minus 1 is 0, denominator is 0. It's undefined. So the derivative is undefined. F prime of x is undefined when x is equal to 1. F prime of 1 is undefined. So f of x is not differentiable at x equals 1. Okay, so we took the derivative, we checked if it is defined. What makes denominator 0 makes the function undefined. So 1 makes denominator 0, it makes the function undefined. So it makes the derivative undefined. If derivative is undefined, it's not differentiable. That's the idea. All right, next question. We can solve the next question by either using the idea of having a vertical tangent here. If you remember in the first part of the first video, if we have odd divided by odd power, the top is less than bottom, so we say it's vertical tangent. So whenever you have vertical tangent, then it's not differentiable at that vertical tangent point. What is the point that makes it vertical tangent? What makes the base 0? X plus 2 0, then x is negative 2. So there is vertical tangent at x is negative 2. F of x is not differentiable at x equals minus 2, we can say, because we have vertical tangent. The graph is something like that. Or a second way, you may not think of this, you just take derivative, it's easy to take. F prime of x equals, apply power rule, 1 over 3 in front, x plus 2 to the power of 1 over 3 minus 1, it's minus 2 over 3. Let's get rid of that negative exponent by moving the variable down in the denominator. Okay, now it is 1 over 3 cubic root of x plus 2 squared, we can say, or this, it's the same. So is this function, is this derivative defined at negative 2? No, it's not. Negative 2 makes the denominator 0. It makes the derivative undefined, so it's not differentiable. Okay, so f prime of negative 2 makes the result undefined. It's number over non-zero, number over 0. So f of x is not differentiable at x equals minus 2.